Okay, now that we have a grasp on the basic unit of matter, the atom, and all the different kinds of atoms, the elements, and how each element is different from the other. All right, let's talk a little bit about matter and how it can change. All right, so you guys know about the Lego pieces. Let's talk about how we combine these Lego pieces together. Okay, all right, so first off, you've got physical change. All right, so physical change, one way to think about it is that if you've got one piece of something and you break it apart, both pieces are still the same thing. Okay, for example, I have a block of ice. I break apart the block of ice. I still have two blocks of ice. Okay, you cut a tree down. All right, both pieces are still wood. Okay, so that would constitute a physical change. Okay, also a change in state. Okay, do understand that changes in state, you still have the same thing, the same molecule. Okay, so a change in state would also signify physical physical change, because at the end of it, it's still the same thing. All right, the properties are still the same. All right, chemical and physical properties still the same. Okay, okay, a chemical change would mean that once this matter changes, the new unit, all right, will have different properties. Okay, and that would signify the change in the chemical composition. All right, that would mean that the molecule has changed into something else. Okay, for example, when you burn a piece of wood, all right, the fire, all right, the fire is actually the plasma part of a chemical reaction that's taking place. Okay, what's taking place is the heat from the chemical reaction is actually grabbing oxygen and using it to break that piece of wood apart and turning that piece of wood into carbon dioxide and other gases. Okay, that's what happens when you guys burn a piece of wood or when fire happens. Okay, all those fires happening all over the place right now. Okay, that's actually a chemical change happening. All right, it's when matter, once you change it, it becomes something else. Okay, the charges are different. Okay, once a chemical change happens, the charges are different in the molecule, therefore the properties are different. All right, okay, now let's go over your different types or forms of matter. Okay, and remember, your forms or types of matter can exist in up to three basic states. Okay, solid, liquid, and gas. And of course, if you want to add on to that, plasma. Okay. Okay. So first off, elements. All right. Elements and compounds. These two types of matter, all right, are known as pure substances. Okay, because at the heart of it, the molecule is the same thing. All right. For example, water. Water has three different atoms. Okay, three different atoms. You've got H2O, right? You've got two hydrogen and one oxygen. Okay, so two types of atoms, three actual atoms, all right, but they are bonded together. All right, so when two hydrogen atoms bonds with an oxygen atom, they chemically change into water. All right, so that would be a chemical change. All right, but water, all right, is the same thing. You have a glass of water, you've got a lot of water molecules that is just H2O, H2O, H2O all over and over and over again. Okay, and that constitutes like a single drop of water. Okay, so that makes it a compound and a pure substance. Okay, so these two types of matter or forms of matter are known as substances. Okay, it's elements and compounds. All right. Okay, elements, of course, they are the basic building block, and that's why you cannot separate it further. The only way you can separate an element is by nuclear reactions, and the chemical equation used is E energy equals mc squared. All right. Compounds can go through chemical change, all right, but they're still known as pure substances. Okay. Okay, here are some examples of compounds. All right. Besides the H2O water molecule I gave you earlier. Okay, glucose, fructose. These are types of sugar. Here's sucrose. All right, table sugar. All right. In 1 grain of table sugar, you've actually got this compound right here over and over and over again. All right. The chemical structure formula for it would be C12H22O11. Okay, if you don't believe me, pause this and count up all these carbons, hydrogens, and oxygens. Okay. Okay, now the other two types of matter, which would equate to four total types of matter, okay, are known as your mixtures. Okay, and this is because this is a physical blend of things. Okay, now there are two kinds of mixtures. You've got heterogeneous mixtures, all right, and you've got homogeneous mixtures. Okay, heterogeneous mixtures, they look different, all right. You can see that it's a mixture. Okay, it's not uniform. Example can be, like trail mix, Rocky Road ice cream, spaghetti sauce. Okay, those are all heterogeneous mixtures. Okay, and look at yourselves. We're also heterogeneous mixtures. Okay, homogeneous mixtures. All right, they look the same. It's uniform. Okay, now not to be derogatory, but that's basically what these words mean. Okay, hetero means different, homo means the same. Okay, at the base of it, that is all they mean. Okay, so homogeneous mixtures, it looks uniform, you can't tell it's a mixture, all right, but it is a mixture. Okay, examples of this can be steel. All right, steel is actually a mixture of carbon and iron, if you guys didn't know. All right. Another example of a homogeneous mixture is coffee, okay, or salt water, or sugar mixed with water. Okay. Now, do understand that all mixtures, even though it's hard to comprehend, theoretically can be physically separated. Okay. For example, steel. If you heat steel enough to where it melts, all right, then you add carbon into it, right? I mean, you take the carbon out of it, then of course, you're left with the iron and the carbon. Okay, and that's how you would physically separate, you know, iron from carbon in steel. Okay, with sugar water or salt water, same thing. Okay, you just boil out the water and you've separated the water from the salt. All right, or you let it evaporate and you've separated the water from the salt or the sugar. Okay, and that's actually how you guys make rock candy. If you guys haven't done that, okay, if you guys don't have a childhood, go make rock candy. Okay, mix sugar, water, boil it up. Okay, make sure you don't burn it. Put more sugar in there, and then you let it sit. Okay, let it sit, let it evaporate, and eventually you will create sugar crystals that grow, and you have your rock candy. Okay, I like this one. Hey, take your heterogeneous mixtures and stir it up. Okay, here's a quick recap. Right, we're all made of atoms, different kinds of atoms known as their elements. There's hydrogen element, carbon element, oxygen element. Okay, atoms and elements combined chemically to form molecules and compounds. Okay, like water. Okay, all right. Okay, so here, right here, is their example. All right, this is a mixture. If you can tell the difference, then it's a heterogeneous mixture. If you cannot tell a difference, it's a homogeneous mixture. Okay, these two right here would be a compound by itself, and then this green ball right here by itself would be an element. Okay, so a quick recap of how matter changes physically or chemically, and then your four different types, all right, of matter that can change in these two ways. Okay, and that's all for you guys for today.